Welcome back, students. Let's get back to the chain rule. This is a statement of the chain rule. This is a step-by-step process. Number 1, outside in. Number 2, inside stay the same. Number 3, the derivative of the inside comes like a dangling chain. Okay, that's the chain rule. We went through elementary exercises. A little bit harder, but still elementary exercises. Combination with product rule, quotient rule, and chain rule. Okay, these are the most important type. Second derivatives, okay, maybe getting a bit too deep, but we can certainly consider them. Just repeat the derivative computation. Trig functions, these are all important. Some elementary examples like product and quotient rule only. And then those associated to chain rule as well as product quotient rules. The final topic, tangency problems. This is the slope point equation of the line. The slope is the derivative evaluated x0, and the point is x0, comma y0, which is the function value f of x0. Here is the step-by-step process. First, find out y0. Next, the derivative function. Find out the slope by plugging x0. Finally, we have the equation of the line, the slope point equation of the line. Let's go. How about something like this? Easy. What's the point? Why not? It's just this function here, evaluated at x0, which is -1. So let's just plug in -1 in place of x, and what do you get? We get square root of 1 plus 1, that's square root of 2, and that's gonna go right here. Next, the derivative function. This is 1/2 power function, so 1/2, and then inside never changes. The power, subtracting 1 from the power, so we get -1/2 power. Is that it? No, not really. We still have to consider the chain part, the derivative of the inside. That'll complete the derivative computation. Now, let's do a bit of a simplification because this problem goes a bit further. Not just a derivative computation, but we have to find out the slope. We have to do some numerical computation. For that purpose, simplification is a little bit better. So this 2 and that 1/2 cancel out, and the negative power is equivalent to denominator, so let's go like this. That's a derivative. Consequently, the slope is this thing evaluated at x equals to -1. So what do you get? -1 over square root of 2. There goes your slope. So your slope point equation of the line, this one, looks like this. Slope y equals to slope x minus x0 minus plus, and then y0. This is y0. That's it. You don't have to simplify. Slope point equation is just as good as any equation. I checked all the all the web assigned homeworks related to equation of the tangent line. They all accept slope point equation. Okay, let me show you the answer key here. Exactly the same, and also graphical justification. Here's a graph, and then the tangent line, and tangency at x equal to -1. Everything is clearly visible. Let's do this again for a little bit harder problem, but this is almost equally as elementary, so I'll just go ahead with usual speed. Let's see, how about y0 value? It's just the function value evaluated at given x coordinate value. So let's just plug in x equals to -1/3 here. So what do you get? we get log of 1 plus 2 times exponential of, what's this? 3 times negative 1/3, so negative 1 plus 1. We get e to the 0 power. And e to the 0 power is 1, isn't it? So this whole thing is becoming log of 1 plus 2, so it's log of 3. Alright, that's this value here. Next, the derivative. Derivative of this log function. Alright, let's use the chain rule. Derivative out of function 1 over x. So this is going to be 1 over whatever inside. Next, we have to multiply the derivative of the inside. You can multiply here, but if you multiply like this, the multiplication will apply to the numerator. So let's just go ahead and multiply here and do everything here. Derivative of 1 is 0, no problem there. And how about the derivative of the exponential? Exponential function always remains the same. And there goes the derivative. Or, okay, if this had been in class, I would have just moved on as if I just went on like that and then wait for some students to correct my mistake. This is kind of awkward here. It's a little bit difficult to make intentional mistakes here. Anyway, let's suppose I did, and let's suppose there is a clever student who remembered the chain rule and reminded me of that. You have to multiply the derivative of the inside, which is 3. So that completes the problem. Let's simplify this thing a little bit. 6 exponential of 3x plus 1, and the denominator is 1 plus 2 exponential of the same thing, 3x plus 1. This is a derivative function. Next, slope. The slope. All I have to do is plug in x equals to negative 1 here. And this 2 is negative 1. Negative 1/3, excuse me. Negative 1/3. So this whole thing is negative 1. So negative 1 plus 1. What do you get as an exponential? 6 times e to the 0 power over 1 plus 2 e to the 0 power. E to the 0 power is 1, so you get 6 over 1 plus 2. Oh, 6 over 3. There goes my slope. Alright, that tells me that the equation of the tangent line in slope point form is x minus of negative 1/3 plus log of 3. This is the equation of the tangent line. Let me open up the cell and show you the picture. Here we go. Slope is 2 and y coordinate of the point is log of 3. At that point, we get this red line. Tangent at negative 1/3. Yeah, more or less visible. This is a computation.